Dear students, today we are going to discuss about static and dynamic memory allocation in C. Let's start with static memory allocation. Static memory allocation is that here the memory is allocated for variables at compile time. So what is mean by compile time allocation? As you all know already, if you want to define any variables, you will be defining like this: integer a of 5, float b, character c, like this. So during this time, we know that memory is allocated for all these variables. Integer means 2 bytes. So here it is array. So 2 into 5, 10 bytes will be allocated. And for float b, it is 4 bytes. And it is for character c, it is 1 byte. So this is actually called compile time allocation, or we call it as static memory allocation, because static means it cannot be changed. It is only fixed. Once it is fixed during compile time, it cannot be changed later. That's why it is called as static memory allocation. Here the memory is allocated in a stack part or else in the data segment part. So we have a stack part, a data segment part, and a heap memory. All these are types of memory where data will be allocated the memory. In case of static memory allocation, data may be allocated in stack memory or in data segment memory. It is faster but less flexible because we are not able to change later the size of the variables. Like for example, here I have given array of 5 variables. Later if I want to extend the variables, like instead of 5 I want 10 variables to be stored, it is not possible in case of static memory allocation. That is a disadvantage of static memory. So that's why we move to dynamic memory allocation. So what is dynamic memory allocation? Here the memory is allocated during the runtime, and where it is allocated in the heap memory. Example functions to allocate dynamically are malloc, calloc, realloc, and then free. Malloc is called as memory allocation. Calloc is contiguous allocation. Realloc means reallocate the memory. Free means free the memory what is already allocated. We'll see one by one in the next slides. And it is actually flexible, but it requires manual deallocation. Like free, we have to use it. So it's slightly slower because it includes runtime overhead. During the execution only, we are going to allocate the memory, so it increases the runtime. Here is an example for malloc. If you use malloc or any other memory allocation function, then you have to use the header file stdlib.h. Here the purpose of this program is to create an array during runtime. This of integer array and needs 5 variables to be stored. So for this function, how we are going to allocate the memory, we'll see here. See here I am allocating first integer pointer, and the pointer name is ARR. As you know already, if you declare any pointer like this, then it is able to store the integer variables. So I am now going to make this as actually a array of values. The starting address will be pointed by this ARR. So here this is actually a syntax for malloc. Malloc takes one input, which is the total number of bytes to be allocated. So here I want to make this ARR as an array, an integer array. So size of the integer is given, and how many integers I like to store? 5. So 5 multiplied by size of integer will give you 10. So totally 10 bytes will be allocated for ARR, so that I can store 5 integer variables here. So once you complete this, it will malloc will return starting address where actually the memory is allocated to the ARR pointer. So now ARR is pointing to 10 bytes continuously, and starting address is available in ARR. In the next step, I am assigning values to these pointers. So I plus 1, I plus 2, like that. It will have the values of I assigned to in the respective index values. Now I am displaying the values what we have stored already. So once you run this program, you will have the output like this. So whenever I equal to 0, array value of 1, I equal to 1 means array value is 2, I equal to 2 means array value is 3, like that. 5 values stored in the array, that is what actually we are displaying. After completing all this, we are reallocating, deleting the memory which is already been allocated by malloc using this free. So this we must do for any memory allocation, dynamic memory allocation. If you use, at last we have to free the memory on our own. So this is how actually malloc works. Next, calloc. Actually both calloc and malloc are having the same purpose, but during creation, whenever you don't initialize, in case of malloc garbage values get stored, but in case of calloc it will be initialized to zeros. So that is the only difference. And here the inputs are actually two. One is the numbers, how many numbers you want, and then the bytes. So these two inputs you have to give it for calloc. In case of malloc, will give you only the total number of bytes to be allocated. So that is the difference between malloc and calloc. The remaining are same purpose only. You can use either calloc or malloc. And what is realloc? So realloc is that whenever you are defining any number of bytes for a variable and later you want to extend or increase the size of the same variable, then that you can do it with the realloc. See here, initially malloc uses to create the array of 3 numbers here. After that I want to extend it to 5 variables. So here I am going to use realloc. So now I am going to extend the pointer size ARR for total of 5 into size of integer, so 10 bytes. So now the memory is reallocated for ARR with 10 bytes. Again I am inserting 2 more values from 3 to 5 here. Then I am printing all the values here. So once you print it, in the first insertion we might have inserted 1, 2, 3, and after reallocating we have inserted 2 more, that is 4 and 5. So with that we got this output, and after completing this program you have to use the free for removing the memory, otherwise it will become a dangling pointer. That is a disadvantage that we have to do it. So the last one is free. So already, as I said, whenever you use any dynamic memory allocation, at last we have to free the memory, otherwise it will become a dangling pointer. So that we have to avoid. So that is what actually memory deallocation. That here we can explain. See here, after removing the memory or deallocating the memory, if you try to access the same memory location, here you may see that there are values which are not actually already allocated. Some unknown values will be displayed. So these 5 actually before allocating the memory, before deallocating the memory, and the remaining in outputs will give you after deallocation. There is no value stored, it is some garbage value it is not needed. So this is how actually free works. So at last, we like to summarize the static and dynamic memory allocation. In case of static, it is done during compile time and it is of fixed size. We can't change during the execution, and it is a bit faster because it is done during the compile time itself, and the memory is allocated in stack part or in data segment part. So in case of dynamic memory allocation, the memory is allocated during runtime and it is of flexible size so that you can allocate and reallocate later. Slightly slower because it is done during the runtime, and the memory is allocated in the heap. So that's all about static and dynamic memory allocation. Thank you.